Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. Okay, so let us start our work for today. This is a picture from 15th century Europe. These are sailors who used to sail in their ships for very long times, for months on end, because remember in those days ships had sails. They did not have engines like today. And when they used to sail for long periods of time, they ran out of whatever food they had carried from the port, and they had to survive on fish and whatever else they could find. So it was discovered that many of the sailors on the ship, they started developing diseases. They became lethargic. They started bleeding from their gums. Their teeth started falling off, and they developed bruises and petechiae on their body, and ultimately they died. Now people are wondering what's going on. Why are they behaving like this? What is happening? So if you had been a doctor at that time, this is what your patient would have looked like. Completely listless with sunken eyes, and on his body you will find such petechiae. Petechiae means little spots of blood, and sometimes even bigger bruises are found on the body. You open his mouth and what do you find? That the teeth are loose and the gums are loose, they are spongy and they are bleeding. So what is the diagnosis? It is vitamin C deficiency, which is called scurvy. What is vitamin C? That is our topic of discussion for today. Vitamin C is also called ascorbic acid. So the learning objectives for today's lecture are: what is the requirement for vitamin C? How does vitamin C become a vitamin? Number two, what are the sources of vitamin C? How much should be taken daily? What are the physical and chemical properties of vitamin C? And what is its metabolism inside our body? What are the functions of vitamin C? And finally, what is scurvy? What are its signs and symptoms? And what are the lab investigations? First of all, the requirement of vitamin C. Now, it should be noted that most plants can synthesize their own vitamin C. So in these plants, vitamin C is not required. Most animals also synthesize vitamin C, so they also do not need to take vitamin C in their diet. How do they synthesize vitamin C? They synthesize it from glucose. Glucose goes through this uronic acid pathway. Glucose changes to glucuronic acid. Then glucuronic acid changes to glucuronic acid lactone, then gulonolactone. Finally, gulonolactone is acted upon by this enzyme, L-gulonolactone oxidase, which then changes it to 2-keto-gulonolactone, which is then ultimately converted to ascorbic acid. So all these animals and plants, they possess all these enzymes, and hence they have no problem. In them, glucose easily changes into ascorbic acid, and so they don't need to consume extra ascorbic acid. The problem arises in man, in whom this enzyme is missing, L-gulonolactone oxidase. So humans, monkeys, apes, guinea pigs, bats, some birds and fish, they are the ones who lack this enzyme, L-gulonolactone oxidase, which is necessary for the synthesis of vitamin C from glucose. And thus, in these species, it is essential to take vitamin C in the diet. Now, in case of monkeys, apes, guinea pigs, bats, etc., their staple diet is plant-based. Birds also, their staple diet is plant-based, and so no deficiency of vitamin C is observed here. So we don't find scurvy in these animals. Where is vitamin C found in our diet, in human diet? All kinds of fruits and vegetables contain vitamin C in varying amounts. As you can see, citrus fruit is the richest source, but beyond citrus fruit, green peppers, strawberries, tomatoes, broccoli, sweet and white potatoes, they are all excellent sources of vitamin C. So you can see all these fruits and all these vegetables, they all contain vitamin C. Fruits like guava, citrus fruit, melon, pineapple, banana, apple, peach, apricot, strawberry are all loaded with vitamin C. And of course, citrus fruit is the richest source of vitamin C, and hence it's a very good source. In vegetables, of course, green pepper, tomatoes, lettuce, onion, carrots, spinach, cabbage, cauliflower, pea, potato, all these contain vitamin C. In animal products, a little bit of vitamin C, although it's a water-soluble vitamin, but a little bit is stored in the liver, very little bit is in milk. What is the daily requirement for vitamin C? As we can see in males and females, there's not really much difference. Up till 18 years, their requirement goes on increasing with age. So up till the age of 18 years, 65 to 75 milligrams is adequate for both boys and girls. But 19 years and above, the requirement in boys increases a little more. But pregnant and lactating females have a higher requirement. In pregnancy, the requirement goes up to 80-85 milligrams. And in lactation, it can go up to 120 milligrams daily. The vitamin C that we consume in our diet is absorbed from the small intestine. From there, it goes to the blood, and then it goes to the various organs where it is going to be used, and a small bit is going to be stored in them also. Where is it used? Mostly in our adrenal glands, brain, pancreas, spleen, kidney, liver, lung, heart, muscle. All these are the organs where vitamin C is used and also stored a little bit. The kidneys reabsorb whatever vitamin C reaches it from the blood, and it is reabsorbed and reutilized. So the plasma concentration of vitamin C is usually 1.2 milligram per dl. A little bit is excreted in the urine and sweat if it is taken in excess, in the form of ascorbic acid or as dehydroascorbic acid or as diketogulonic acid or as oxalic acid. What are the physical properties of vitamin C? It's a white crystalline substance which has a sour taste, like the taste of oranges or like the taste of lemon. It is soluble in water, however, it gets oxidized when it is in solution in water, and it is stable when it is dry. It is also oxidized at an alkaline pH because, of course, it's an acid, its pH has to be acidic. It is also oxidized on exposure to light and on exposure to heat, and hence orange juice should never be boiled. Sometimes grandmothers tend to boil orange juice to give it to the children in winter. However, that is going to lose its property. Cooking will make it lose 70% of the vitamin C found in orange juice. And also in the presence of metals, it tends to get oxidized and so it becomes useless. Example, in the presence of copper, iron, etc. Vitamin C is going to lose its properties. This is the chemical structure of vitamin C. It is ascorbic acid, it is an organic acid, and this is its chemical formula. It has 6 carbon atoms, 8 hydrogen atoms, and 6 oxygen atoms arranged in this fashion. You can see that at carbon 1 there is a keto group. Carbon 2 and carbon 3 both have these alcohol groups, and this is the reason why it is such a strong reducing agent. And there's a double bond between carbon 2 and carbon 3, and it also has some more alcohol groups. This is therefore its chemical structure. If we look at it, L-ascorbic acid, this is what it looks like. Carbon 2 and carbon 3 have these 2 alcohol groups, which can be lost. And when they are lost, then it is called dehydroascorbic acid. And these 2 hydrogen atoms which are lost from ascorbic acid can go to cause reduction in other substances. And in the process, ascorbic acid is itself oxidized to dehydroascorbic acid. However, dehydroascorbic acid can take back 2 hydrogen atoms from some other source, which can go and reattach themselves to carbon 2 and carbon 3 and reform L-ascorbic acid. But if dehydroascorbic acid loses more hydrogen atoms, then it gets more oxidized, then it changes to diketogulonic acid, and then it cannot change back to dehydroascorbic acid anymore. So L-ascorbic acid, because of these 2 at carbon 2, carbon 3, because of these 2 alcohol groups, it can lose those 2 alcohol groups. So there is a keto group at carbon 2 and carbon 3 called L-dehydroascorbic acid, and this is how when it loses its 2 hydrogen atoms, so it can cause reduction in other compounds, and itself it gets oxidized. It gets oxidized, but if it takes back 2 hydrogen atoms, then of course it can get reduced back to ascorbic acid. But if dehydroascorbic acid manages to lose even more hydrogen atoms, or it gets more oxidized to diketogulonic acid, then its ring structure opens up and it loses its activity completely. Now it cannot be changed back to ascorbic acid. Both ascorbic acid and dehydroascorbic acid are strong reducing agents. They are responsible for redox reactions. So they act as coenzymes for all kinds of hydroxylase enzymes in our body, because if these hydroxylase enzymes contain iron or copper, then then ascorbic acid can reduce these substances and causing redox reactions, and thus it is essential for the action of the hydroxylase enzymes. Ascorbic acid also acts as a reducing agent to increase the activity of certain enzymes, and it also has some non-enzymic effects. Ascorbic acid is also an oxygen radical quencher, so it acts as an antioxidant. When iron is absorbed, then we all know that ferric form of iron cannot be absorbed. Iron has to change to the ferrous form to be absorbed. If ascorbic acid is taken in the diet along with iron, it manages to reduce ferric iron to ferrous iron, and then ferrous iron is easily absorbed. Ascorbic acid is essential for the strength of collagen in our body. This is what we see in scurvy, all of this is because of collagen which becomes loose, and the collagen which is found in the capillaries, this becomes loose, so bleedings take place, giving rise to petechiae and hemorrhages. Spongy bleeding gums, the reason again is the same, that collagen is not as strong as it should be because of a lack of vitamin C. So let us see how vitamin C acts on collagen. Collagen actually consists of 3 rope-like structures firmly bound together to make a tight rope, and these 3 ropes are held together by hydrogen bonds. Now, how are these hydrogen bonds formed? This procollagen contains a repetition of these 3 amino acids, glycine, proline, and hydroxyproline. In the presence of vitamin C, during post-translational modification, glycine and proline change to hydroxyproline and hydroxylysine. So when this change takes place, when proline changes to hydroxyproline, then more hydrogen bonds can form. And when more hydrogen bonds can form, then this gives strength to the collagen. You can see here the post-translational hydroxylation of proline and lysine, causing them to change to hydroxyproline and hydroxylysine. And this is responsible for making more hydrogen bonds between fibers. So more crosslinks are formed between fibers, and this gives strength to collagen and to osteocalcin. Then vitamin C is also essential as an anticoagulant. We have aspartate beta hydroxylase enzyme in our body, which hydrolyzes and inactivates factor V. This prevents blood clotting. And because this is a hydroxylase enzyme, it needs vitamin C. If it is not present, if there's a vitamin C deficiency, then this enzyme will not act. Carnitine synthesis, we all know that carnitine is found in the muscle and liver, and it is necessary for beta oxidation of fatty acids and the transport of fatty acids across the inner mitochondrial membrane. Carnitine is a quaternary ammonium compound. Hydroxylase enzyme is required for the synthesis of carnitine, and we know that all hydroxylase enzymes need ascorbate. If this is missing, hydroxylase enzyme will not be able to function properly, so carnitine will also not form, and hence all these processes will suffer. Serotonin synthesis also requires carnitine. Tryptophan has to be hydroxylated to form 5-hydroxytryptophan and then to make serotonin. And serotonin is one of the neurotransmitters which, when they are released, then this gives the feeling of relaxation and calmness. The other neurotransmitters are dopamine, serotonin, oxytocin, endorphins, which when they are released, they make us feel good. So when vitamin C is lacking, tryptophan cannot be changed to serotonin, and this makes people feel miserable. In tyrosine metabolism, this is what we see, para-hydroxyphenyl pyruvic acid needs to change to homogentisic acid. And this again needs the presence of vitamin C. In folic acid metabolism, also vitamin C is essential because folate reductase is an enzyme which changes folic acid to tetrahydrofolic acid, and this tetrahydrofolic acid is a cofactor in the synthesis of amino acids and nucleic acids, which is essential for the maturation of RBCs. Now, if vitamin C is absent, then this whole process is not going to take place. Folate reductase will not act. And finally, there will be a lack of tetrahydrofolate, and this will give rise to megaloblastic anemia. Steroid synthesis also requires vitamin C, because in the adrenal cortex, where the adrenal steroid hormones are synthesized, like cortisol, aldosterone, androgens, they are synthesized. They all need a lot of hydroxylation reactions go on for their synthesis, so they all need the presence of vitamin C. In the liver also, cholesterol needs to change into bile acids and bile salts, and this also requires the alpha hydroxylase enzyme, which again needs vitamin C. And hence a little bit of vitamin C is also stored in the adrenal cortex and liver. Ferric iron, when this is found in hemoglobin, then gives rise to the disease called methemoglobinemia, which will make a person all cyanose, because methemoglobin, which contains iron not in the ferrous form but in the ferric form, will not be able to carry oxygen, and this gives rise to cyanosis. Normally, vitamin C changes methemoglobin back to normal hemoglobin, but if vitamin C is absent, then methemoglobin will accumulate. It will not change to normal hemoglobin. Many peptide hormones also have a C-terminal hydroxylated glycine. This hydroxylation also needs the presence of vitamin C, and if this is not there, then hydroxylated glycine will not form. Catecholamines, dopamine beta hydroxylase is a copper-containing enzyme in the adrenal medulla and in the CNS. It synthesizes epinephrine and norepinephrine from tyrosine in the presence of copper. Q+ needs to change to cupric during hydroxylation. And this cupric needs to change back to Q+, and this reduction again needs the presence of vitamin C. And if vitamin C is not there, then this is also not going to take place. This is the synthesis of catecholamines, and we can see how ascorbic acid is essential. For the synthesis of norepinephrine from dopamine, ascorbic acid is highly essential. Then ascorbic acid also has antioxidant property. It regenerates the functional reduced form of vitamin E, and it prevents injury from free radicals or toxic oxidation products, which can give rise to cancer, aging, immune disorders, coronary artery disease, cerebral function. All these are the problems with the superoxide radical and other such oxidants. So vitamin C, along with vitamin E, it is necessary to act as an antioxidant to prevent from these dangers from toxic oxidation products. So this is how vitamin C acts as an antioxidant. Vitamin E is an antioxidant and a reducing agent. It has a hydroxyl group at the end, which donates the hydrogen atom in an antioxidant reaction, which converts it to a quinone. Now, quinones are highly reactive molecules, and they can be associated with cancers, neoplastic disorders, which can react with proteins and make them non-functional. So vitamin C donates a hydrogen atom and a hydrogen ion, which changes it back to the hydroxyl group. This is extremely essential for the action of vitamin E, and this is a critical part of the antioxidant defense system. And if this does not take place, if vitamin C is missing, then all these can take place, these free radicals like the superoxide radical, hydrogen peroxide, etc. They can all cause DNA damage. They can cause fatty acid oxidation, membrane disruption, phospholipid alteration. All these can happen when there are these free radicals roaming around and there's a lack of vitamin C. So this is how vitamin C acts as an antioxidant. Redox reactions also require the presence of vitamin C. How do we investigate in the laboratory for vitamin C deficiency? We usually find the level of vitamin C in the plasma and also in the WBCs. In the plasma, the normal level of vitamin C is usually 0.7 milligrams per dl. In WBCs and platelets, the amount is 25 to 30 milligrams per dl. So this is one way to find vitamin C deficiency. Another way is by the saturation test, meaning we give a certain known quantity of vitamin C to the patient, and then we see how much of it is excreted in the urine. what is the percentage of the oral dose that is excreted in the urine. If 50% is being excreted in the urine, then it's okay. But if less is being excreted, it means the body was hungry for vitamin C and it has stored all that vitamin C inside it and it has not excreted enough of it. That will go to show and it will go to prove that vitamin C was deficient in this body. Then there's another test called the tourniquet test, where we tie a sphygmomanometer cuff on the arm of the patient and we inflate it, and then these petechiae or these little spots of bleeding start appearing on the arm of the patient. When this blood pressure cuff is tied midway between his systolic and diastolic blood pressure for 5 minutes, and if we find more than 10 or more than 10 petechiae per square inch, meaning petechiae means these small spots of hemorrhages, if they are found, then this means that this person has vitamin C deficiency. So what is scurvy? A deficiency of vitamin C, which leads to this condition called scurvy, in which we find that the person feels weak and there is anemia, there is bruising and bruising on his body, these petechiae are found on his body, bruises are found on his body, his gums start to bleed and they become spongy, and his teeth start falling off. So these are the signs and symptoms of scurvy. They generally develop after at least 3 months of a diet which is totally deficient in vitamin C. And this gives rise to weakness and fatigue in the patient, bruising, easy bruising and bleeding. Why? Because collagen is there in the blood vessels walls, and when that collagen becomes weak, then the blood oozes out from these blood vessel walls. So there is a collection of blood underneath his nails, in his joints and connective tissue, etc. His hair start falling off, teeth, there's teeth loss, there's gingivitis. If it happens in infants, they become irritable, they have pain when they move and they lose their appetite. Infants do not gain weight as they normally do. In infants and children, bone growth is impaired and bleedings may be found all over their body and anemia occurs. So this is what we observe. In vitamin C deficiency or scurvy, there is hemorrhagic diathesis. Why? Because the collagen is not supporting the capillaries anymore. The collagen has become weak. There may be subperiosteal hemorrhages, meaning underneath the lining of the bone. There may be hemorrhages in the skin, subungual or under the nails. There will be bleeding in the joints, teeth loss, and bleeding in the gums. So the gums become spongy and start to bleed. And the person cannot limit infections, so he starts developing cellulitis or pneumonia. His wounds don't heal, and there is arrested skeletal development in children. So all this takes place in scurvy. Here you can see on the legs and on the arms, there are these small dots of hemorrhages called petechiae. And his gums are all swollen up, and his teeth will soon become loose and they'll fall off. So in severe cases of scurvy, gums become painful, swollen and spongy. Pulp is separated from the dentine, and finally the teeth are lost. Wound healing may also be delayed. In the bones, the deficiency results in the failure of the osteoblasts to form the intracellular substance, the osteoid. And this happens, of course, if the person remains for 3 to 4 months on a diet which is totally devoid of fruits and vegetables, because vitamin C is found only in fruits and vegetables. Infants with delayed weaning, if infants are just given milk and they are not started on fruits and vegetables, then after some time they can also develop scurvy. So the symptoms of scurvy are a lack of collagen synthesis, capillary hemorrhages, muscles become weak, soft swollen gums, loose teeth, delayed wound healing, lack of development of bones, cartilage and dentine, old fractures break down, there are petechiae, ecchymosis. Petechiae are the small pinpoint hemorrhages, ecchymosis are the big bruises. Outward bleeding can take place from the GI, from the mouth, from the anus, from the nose, in the urine. Anemia because of all these hemorrhages, joint pain because of bleeding in the joints, scorbutic rosary where the sternum seems sunken. A scorbutic rosary actually means that under the periosteum of the bone there has been bleeding, and so it seems, rosary means a tasbih, so it seems as if there are bleeds, as if there are beads on the bones which are joining with the sternum. The point where the ribs join with the sternum, at that point it seems to be swollen up like a bead because of subperiosteal bleeding. And finally, it can lead to death if symptoms remain as such and they are not corrected. Can we take too much of vitamin C in our diet? The answer is no. It is a water-soluble vitamin, so it's safe. The only problem that can arise with mega doses for a very long time, when we are in fruits and vegetables, of course, there's no danger of toxicity. But if somebody is consuming extra amounts of vitamin C in medicinal form for a very long time, huge mega doses, then there can be an increase of urinary oxalates. Uric acid stones can form in the renal tract. Or increased intestinal iron absorption can be dangerous if the patient is already suffering from iron storage diseases. So this is all about vitamin C and its deficiency diseases. I hope you've understood everything. And if there are any questions, then of course you all are most welcome to give your comments on the email or in the Google Classrooms. Thank you so much.